Good morning, everyone. This is Dr. Simran Kiani, and I'll be speaking about Diffie Hellman key exchange today. Before we start with this particular topic, let's start with what is encryption and decryption. So, whenever we want to send any confidential data over the internet, as we are aware that internet is an untrusted network, and there are lot many faults or lot many threats that can occur over the internet, and there can be changes in the confidential data, and misuse of the data can also be done. So in order to avoid that, we can have various techniques like encryption and decryption, wherein we will be converting our data into some coded format that is called as ciphertext, and it will travel over the destination. At the destination end, this particular data will be converted from coded text into some normal plain text, original message, and the receiver can get that particular data and then can use it for later purpose. So this is the diagram of encryption and decryption. Now, talking about the aspects of encryption and decryption, the most important thing that is there in encryption and decryption processes is first the algorithm that we are using, and the second important thing is the key that we will be using. So these two are the important things, and there are various cryptographic algorithms like symmetric and asymmetric. When we talk about symmetric algorithms, in symmetric, there is a single key which will be used both for encryption and decryption purpose. Talking about asymmetric, in asymmetric key cryptography, there are two different keys being used by sender and receiver both. One key will be used for encryption, whereas the other key will be used for the decryption purpose. So both these keys are called as public and private key. Public, if we are using public key for encryption, the other key, that is private key, will be used for decryption purpose. So every user will have two set of keys, public and private key. So, whereas in symmetric, there is only a single key which will be used for encryption and decryption purpose. So, the major problem when we talk about the symmetric type of algorithm is the key exchange problem. As we are aware that we are using the same key for encryption and decryption, therefore, how we are going to exchange this particular key with sender and receiver is the most difficult issue in symmetric type of algorithms. And the second difficulty that occurs in symmetric algorithms is the number of keys used for communication purpose. So it is too high. That is, if we have n communicating parties, so the number of keys required will be n minus 1 by 2. So it is a huge number if we talk about the key exchange. So this is the major challenge that occurs in symmetric algorithms. So in order to cope up with this particular challenge, we have an algorithm called as an Diffie-Hellman key exchange algorithm. So this algorithm is basically used for solving the problem of exchanging the keys, actual keys, between the sender and the receiver without actually transferring the key over the internet. So, for example, if we have two users, Alice and Bob, and they want to communicate with each other, and they decide upon a key without any particular meeting, and in this particular algorithm, there won't be any exchange of the secrets, like secret key and all that. And even if they are not exchanging the keys, we will be calculating those keys at their ends, and later on these keys, secret key, will be used for encryption and decryption purpose. So we will see how this particular algorithm works. So there are certain steps in this algorithm. The first step is, if we have two users, Alice and Bob, so they will agree on two large prime numbers. Maybe we will call them N and G. These two numbers need not be kept secret, and Alice and Bob can use internet in order to transfer these two integers. The second step is Alice will choose another large prime number, that is x, and he will calculate a in such a way that a will be equal to g to the power x mod of n. Once this A is calculated, this Alice is going to send the number to Bob. That is, A number will be sent to Bob. Now, what Bob is going to do is Bob will be independently choosing another number that is called as Y, and then she will be using he will be using this y number in order to y integer in order to calculate b. B will be equal to g to the power y mod of n. Once b is calculated, then Bob is going to send this number to Alice. Once they have exchanged these two numbers a and b, now Alice is going to compute the secret key K1, that is equal to b to the power x mod of n, and b will be calculated, that is Bob is going to calculate the secret key K2, that will be equal to a to the power y mod of n. And now these two keys, that is K1 and K2, will be used for encryption and decryption purpose. Now this is the diagram of this particular algorithm, how the steps are going to work in this algorithm. And finally, we will, at the end of this algorithm, we are going to get K1 and K2. These both will be same. Let's see an example of it. Now, for example, we have been given a problem wherein n is equal to 11, g is equal to 7, x is equal to 3, and y is equal to 6. So we have to find out the value of K1 and K2. So the simple solution to this problem is first Alice will calculate g to the power x mod of n, that is equal to 7 to the power 3 mod of 11. So we get a is equal to 2. Now this a will be sent to Bob. Bob is going to use it for calculating the key K2. The second step is B will be using y to calculate the value of b, that is Bob will be using the value of y to calculate the value of b. So b will be equal to g to the power y mod of n. So b is equal to 7 to the power 6 mod of 11. So mod here is representing the remainder of the division. So b will be equal to 4. Now once a and b have been calculated, both Alice and Bob can calculate K1 and K2. So K1 will be equal to b to the power x mod of n. That is K1 equal to 4 raised to power 3 mod of n. That is K1 will be 9. And K2 is equal to a to the power y mod of n. So K2 will be equal to 2 raised to power 6 mod of 11. So we have got K2 is equal to 9. So both the values we have got K1 and K2 is equal to 9. As this Diffie-Hellman is used for exchanging the symmetric key, hence we have got our symmetric key value, that is equal to 9. And now this particular value will be used for encryption and decryption purpose. So from this example, you have seen that instead of directly sending the key value 9 over the internet, Alice and Bob are sending some integer values over the insecure internet like 3 and 6, and then these values are being used to calculate our actual secret key value. So this is how the problem of directly transferring the secret key over the internet in case of symmetric algorithms is being done. So this completes our Diffie-Hellman key exchange. I hope you have understood this. Thank you.